to welcome you to the ICRFS-Plus 10.2 video presentations. I dare say that you are going to enjoy these presentations, and I think you're going to find them very exciting. And hopefully, as a result of viewing these videos, you are going to get back to us and invite us to give you an on-site full-scale presentation that would also involve modeling some of your data together with you. I'm going to be switching between three programs. I'm going to be switching between PowerPoint displays, between the ICRFS-Plus program itself, and also our website, just to gather some more information. ICRFS-Plus is a unique, fully integrated long-tail liability enterprise risk management platform. And what does that actually mean? It means that all your data, your models, your reports reside in one ICRFS-Plus relational database. There are a lot of advantages of having a relational database. Now, that database can either be remote, where it sits on the server and it is shareable amongst the various clients, or it could be a database that just sits on your own computer, on your workstation, or on your notebook. And communication between a remote database and a local database is pretty effortless and seamless, and it has the kind of same intuitive feel as using Windows Explorer for managing files in subfolders. You probably know that in Windows Explorer you might have two subfolders open. You would highlight a particular file or subfolder on one side, grab it, drag it, and drop it to another subfolder. Well, ICRFS-Plus works in the same way. An ICRFS-Plus relational database is a repository for all your data, for all your models, and also links to reports. These reports could reside in Excel or Word or some other Windows application. You could configure your database in any way you like in terms of any classification variables you would like to have. The database, this is one of the unique features of ICRFS-Plus. The database facilitates the understanding of the long, short, and short tail. ICRFS-Plus can also be used for short tail, and I'll explain that a little bit later. Risks in a quantifiable and integrated manner. And this has great advantages over having your data, models, and so on in something like an Excel spreadsheet, where it becomes pretty unwieldy to find something, to go to a particular line or to a particular column. And of course, you all know that if you change one number in your spreadsheet or one part of the calculation, it might have impact on other parts of the spreadsheet. It's very hard to peer review and so on. Well, those kind of problems you don't have with ICRFS-Plus. Everything resides in one database. It is very easy to navigate through the database. It's very easy, once models are stored, to create forecast tables, distributions, and lots of other related output just with a few mouse clicks. Communication with other software using COM scripts is also effortless and pretty seamless. ICRFS is COM-enabled, which means that you can write, say, Visual Basic script in Excel to, we'll see later on, to input data, to manipulate objects in the database, to create reports, to communicate with any other software, any other COM-enabled software in an effortless and seamless way. Well, let's go to the product itself. And here's a database, and a database contains objects within it, and the objects are called triangle groups. So you can see that we have listed alphabetically triangle groups. There are lots of them. A triangle group is a collection of loss development arrays or triangles, paid losses, incurred losses, number of claims reported, as many triangles you like, and the triangle group will be in respect of a particular piece of business. It'll have all the triangles. It will also have models. It will also have links to reports and other pieces of information. You can also have what's called a composite or composite triangle group. A composite triangle group is actually linked to other triangle groups. So the basic unit of a database is a triangle group. Another unit or object in the database is a composite triangle group. You might be interested in modeling the relationship, say, between 5 lines of business. Each line of business is represented by a triangle group. The composite will be the 5. They're all linked, so you can design a model that actually not only measures the variability within each line of business, but also measures the correlations, the 2 types of correlation we'll discuss between these 5 lines of business. For my database, I also have variables. Here are some variables. Client name is a variable. I have these as client names. Of course, if I wanted to add another client name, I just add another value. Location is a variable. Line of business is a variable. Currency, you can make any variable you like. Inflation, well, that's a variable or an attribute that you can only assign to a triangle group after you've actually modeled it. So you've modeled a particular triangle group. It turns out that it's got inflation in excess of 20% for most of the calendar years. Then you would assign it that attribute. Is the data net of reinsurance, or is it gross? Territory, I guess, is a bit like location. Process variability is, again, a feature of the data, and it's an important feature of the data. It becomes integral to the model. And once you've modeled some data, you want to know, is the process variability between 0.2 and 0.5? Is it less than 0.1? Is it greater than 1? And so on. Is it company data or industry data? What type of coverage it might be? And so on. Okay, let's go back to Triangle Groups tab. Now we've got a tree structure here. All these variables are in the database: client name, location, line of business. Let's open the tree by client name. So you click on the plus, and if we select E&Y Atlanta, all these triangle groups have the attribute that the client name is E&Y Atlanta. If instead we select M, then we find that all these triangle groups have the client name M. Incidentally, a triangle group that has these triangles here as an icon here, and there's also the burgundy or red, represents a composite, whereas the other ones here are actually a basic triangle group. If I dig down further into the variables, click on the plus, and now look at the tree branches by line of business. If I click on Auto BI, well, the client name is M, the line of business is Auto BI. If I now click on medical malpractice, it's still the same client name, but the line of business now is medical malpractice. Instead, I might want to do a search which is different, and I might look at, say, line of business, and I just look at professional indemnity. And there's lots of those. Then I can open this by, say, company name, so client name, I'm sorry, and select M. Of course, another way of finding something is a query view. You might have a very large database. One of the databases that we look at in a subsequent video, I think it's probably chapter 4, we'll look at the A&BES Schedule P, all converted to an ICRFS-Plus relational database by client name, line of business, whatever other variables are in Schedule P, and therefore, because it's a very large database, you might want to submit a query. For instance, if you double-click on client name, if you type the letter M, anything that starts with M is listed. Another M, well, that's your M. Or you can then go to, say, line of business, double-click on, let's do M again and press return. And now line of business, and choose, say, order BI. So it's A. Well, that's our selection. And the client name is double N. The line of business starts with the letter A. An alternative, if I use the control key and double-click on client name, then I can select, say, ENY Atlanta and ENY, and then I can go to line of business and just select, say, professional indemnity, and so on. So it's pretty easy to find something. You know, if you're a consultant, of course, one of your variables could be client name, another variable will be line of business, another variable could be currency. Whatever variable you like, you can create it, and then apply attribute values to the triangle. In fact, why don't we do that? Why don't we go to variables and add another variable? Let's call it, what do we want to call it? We want to call a new variable. Well, let me just call it junk. So I've got a new variable junk, and one value will be, say, J1. I go back to triangle groups. Suppose I select these triangle groups. I assign values. I just use the right mouse click. The right mouse click brings up what's called a context-sensitive shortcut menu. So anywhere you are in the system, the right mouse button will bring up that context-sensitive shortcut menu. Junk, J1, apply that. So now if we scroll to the right, you'll see that J1 has been applied to, there it is there. If I now go to tree view, I go to junk, and I just select J1, well, that's the triangle groups. Of course, I can go back to my variables. It's a variable I made up. Why don't I just delete it? Variable junk is in use. Doesn't matter. I'm not interested in it. Yes, and it's gone. Okay. What's in a triangle group? So let's select the triangle group. And the triangle group has objects within itself. Now, let's look at some of the basic objects inside a triangle group. And triangles, so we've got paid losses, case reserve estimates, number of claims reported, number of claims closed. Paid losses again, but C stands for cumulative. The scale, is it in thousands, millions, whatever. Categories at original data, it might be simulated. If we look at the first object in our database, in our triangle group, then paid losses, so let's open that up. That's a view, the standard view of a triangle, where the rows are the accident periods, the columns are the development periods. If we want a different view, we can change the view with the right click of the mouse button. And let's go to accident by calendar period. So now the columns are actually the calendar periods, just a transpose of the same matrix. So we've got these triangles, we've got number of claims reported triangle, and so on. If we now go to dimensions, that's dimension of every array in this particular triangle group. Of course, we can have any dimensions we like, and I'll show you right now. If I go back to the database and I want to create a new triangle group, let's call it junk, and let's give it a variable value. Let's call it client name, demonstration projects. Now the dimensions, so the sampling period, we could have accident years, so let's make the first accident year, say 1979. The last calendar year, calendar samplings, why don't we make it quarter years? So now the development periods are actually quarter years, and the accident periods are actual years. So you can make the last calendar quarter let's make it the last calendar quarter, say 2006, for say third quarter of the year. The triangle could be truncated. Let's make the first calendar quarter 1986. First quarter. The last accident year, well, it's the same as the last calendar year. The last calendar year, accident year, will be 2006. Okay, let's look what the shape is. So that's the shape. So it's pretty flexible. I mean, the early calendar periods might be missing. We don't have any data there. In fact, with this product, you can model 3 diagonals. In fact, if you find out later, the flow of information is along the diagonals of the calendar periods. And the most recent data is really along the last diagonal. Now, why is it useful to have calendar periods that could be quarter years, but the accident periods are years? Well, you might be interested in the reserves for specific 12 months periods, which we call the accident years, but you want to do a valuation every quarter year. So in that case, your development periods and calendar periods are quarter years, excuse me, but your accident years are years. Or you could have calendar periods that are 12 months period. You do your reevaluation every 12 months, but calculate accident year reserves. Okay, we're going to cancel this. That within this triangle, or lost development array, it might be a circle. You can actually model a circle as long as you've got the 3 directions, and the rest is essentially missing data. Okay, let's cancel that. Let's go back to company A, and we've looked at dimensions. We might also have a set of notes. We might have reports that are linked to our, well, in this case, it's Excel spreadsheets. We've got exposure, inflation premiums, base exposure. Okay, we've got an inflation vector. We've got a data set. A data set is a triangle plus an exposure vector and possibly an inflation. So you can have 2 triangles that are the same. These are 2 paid losses. One uses 1 exposure. The other one doesn't use any exposure. Let's change that. Okay, a model. Models represent structure in the data, and structures in the data are represented by 4 easily interpretable pictures. Every model is just represented by 4 pictures. Later on, we'll learn how we interpret these pictures and how we design models. Okay, now let's suppose we want to create a new database. So we'll go to new database. Let's call it new. The date today in Australia is the 13th, say 02/2007. We're going to close the other one. So now we have a new database which is empty. We're going to delete these 2 variables which are there by default. We're now going to go to another database. So now we have 2 databases. We've got a client name. We've got a triple M, say, control. I guess, well, that's one way of highlighting everything, or you could just done control A, and let's paste them into the other database. So you'll see not only the triangle groups, and some of them are composite, 2 are composite, that we are transferring, but we're also going to transfer the corresponding variable values, the variables and their values that are assigned to each triangle group. If I look at a preview of this triangle group, and I look at a preview of this one, well, the previews at the bottom of the page should be the same in each case. If I delete this model, then I can always grab the one on the other database and drop it on top of that triangle. There are occasions when segments might be related, layers might be related, where it makes sense to grab a model for one particular triangle, drop it on another triangle, and then see in a number of seconds whether it actually works, whether it's an appropriate model for the other triangle. Let's close these 2. Let's go back to my PowerPoint display. I'll reopen the original database. Let's go back to PowerPoint. Now, communication with other software using COM scripts. How do we populate a database? A database, as I've mentioned before, could be remote or it could be local. The ones we just looked at were local. Let me bring up the pointer option. And how do we create a database? How do we populate it? Well, we'll look at two distinct examples here. Let's suppose your data, your triangles, your loss development arrays are currently warehoused in some other Windows application like MS Access, Oracle, SQL Server, Excel, or maybe just some kind of CSV file. You can write, and we also provide you with templates, COM scripts, Visual Basic commands, say in Excel, that will take the triangles, and we're going to do this in Chapter 4 of the video demonstrations. We're going to show you a few examples, real live examples where we do this. So you've got some COM script in Excel, you run it, the triangular data that resides in any one of these applications will be seamlessly imported into ICRFS-Plus relational database. And in fact, you can conduct the importation so that you already have variables in the database like client name, company name, whatever, line of business, and so on. What if instead your data is not triangular, it's really unit record transactional data? If it's unit record transactional data, it could be residing again in MS Access, Oracle, SQL Server, Excel, or some flat file. You can submit queries using COM automation to the unit record transactional data, and those queries will create triangles, loss development arrays, and again import them into an ICRFS-Plus relational database by client name, what other variables you have. Now, once you've created the relational database, there are other operations that you can perform on the database using COM automation. For instance, you can manipulate any objects in the database. So let's suppose that in each triangle group, you have paid losses cumulative, and you have the case reserve estimates or the incurred data. Let's look at an example that we could do manually. So let's go back to demo projects, COMPay, it's real data. Now, if we go to triangles, we can see that we've got the incurred data, and we've got the paid data, and we also have the case reserve estimates. If I delete the case reserve estimates, no, it can't be deleted because it's already in a particular data set. Okay, I can't delete it because it's already been associated with something. So let's remove this association. There's no association. Let's go back to triangles. There's also a data set, so let me delete this data set first. Let me go back to triangles. Let me delete the case reserve estimates. Hopefully I'll be able to delete it now. Well, I can recreate it manually by highlighting the paid losses and the incurred and going to this button here, and it creates the case reserve estimates. Well, that's an operation that I conduct for that particular triangle group. However, let's suppose that you've got hundreds of triangle groups, and instead of doing this manually for each triangle group, you can write Visual Basic script in Excel, say, that will go through each triangle group and create the case reserve estimates from the other two triangles. You can also use COM automation to update the whole database each quarter year, and to run the wizard. There's a modeling wizard. You can use that. You can, when you update the database, you update each triangle group, and you also update each model. You'll see one of the advantages. There's so many advantages. The product is so full of so many rich statistical ideas, and you'll see also that the interface, the user interface, is unique. The computational speed is just incredible, and so on. And the rest of the introduction, in terms of the system, will be given in the next video. Thank you.